Problem number 6 from your review are a bunch of definitions, and in a test situation you'll probably see these definitions. If they were going to pop up, they would be in the first problem, or the first set of problems. Here we're asked to find the random variable, probability distribution, uniform binomial distributions, and expected value. So let's take a look at the first two. A random variable is really just a variable that's assigned a number. So a variable described the outcomes of a statistical experiment in words is something that was written in your textbook, and I'll take that as a random variable definition. A probability distribution assigns a probability to each of the random variables. And so that's the definition for a probability distribution. It's asking us now to give a definition for the uniform distribution. So uniform distribution is our first example of what they call a continuous probability distribution. Uniform distribution is a continuous distribution that has an equally likely chance of obtaining values within an interval. And your interval would be whatever your low value is and your high value is. And so you see these things in a textbook and also in your homework set. And what they are ways to represent your particular distribution. So in our case, the U stands for uniform distribution, and there's two parameters here, the low and the high. So that's a uniform distribution. A binomial distribution has to satisfy a set of criteria that describes a binomial experiment. A binomial experiment has a fixed number of trials, and we can denote the fixed number of trials by n. And then it has two possibilities, a success or a failure for each of those trials. And the probability of getting success for a trial would be p. Now it says here the trials are independent also. That gives us the fact that for each time that we select, for each time we run through the trial, it's independent of the previous trial, so that says that our probabilities for each trial will remain constant. So having a binomial experiment leads to a binomial distribution. So the binomial distribution notation for us is going to be an x is equal to, or that tilde thing. And they use b for the binomial experiment, and then they ask for two things. First thing they ask for is the number of trials, and then the other thing that they ask for is the probability. So with these two parameters, we're able to describe the binomial experiment. So here's our notation for a binomial experiment. Expected value. For expected value, what you can do is just take a look at your textbook, and when it starts talking about the mean or expected value, it's exactly what it is. The expected value is really just the mean. The thing about describing expected value here for probability distributions is that we often use the mu for this, and so also we look for the standard deviation. And for standard deviation, I've said that we're going to be using s for the notation for the standard deviation. But when we're dealing with probability distributions, our standard deviation is going to be denoted by sigma. So keep that in mind when you're describing the standard deviation. Okay, so our expected value is really the mean. Alright.